Okay, this is the first lesson on binomial expansions for year 13. It's chapter 4 in the Pearson's book 2. In order to get to grips with binomial expansions in year 13, we need to recap the chapter in year 12. And I just want to do that very simply with one example. If I'm writing down, or working out rather, the expansion of 4 plus 3x to the power 4, using the techniques that we came across in year 12. Because I've got to the power 4 here, I'm going to write down the numbers in the fourth row of Pascal's triangle, or you can just use the NCR button on your calculator. So those numbers are 1, 4, 6, 4, 1. Much easier to follow, far less likely to get things wrong if you write it out row by row by row for each term. So there are my Pascal's triangle numbers, NCR numbers 1, 4, 6, 4, 1. Now I'm going to do decreasing powers of 4, this number here. So 4 to the power 4 is my first one. 4 to the power 3, 4 to the power 2, 4 to the power 1, 4 to the power 0. So decreasing powers of the first term here, and then increasing powers of the second term. Now bear in mind we need to raise the whole of this, all of 3x, to the respective powers. So 3x to the power 0, 3x to the power 1, 3x squared, 3x cubed, and 3x to the power 4. Make sure there's a bracket around these. If you've got two elements to this, put a bracket around it. Indeed, if there's two elements to this, also put a bracket around it. You rarely see that at A-level maths where you have a variable in this first bit. Once you've written these down, it's just a case of pressing buttons on your calculator, and for this particular example, here is my expansion in increasing powers of x. So x to the 0, x to the 1, x squared, x cubed, x to the power 4. Where this is a natural number, then you have a fixed number of terms here. Okay, it only goes up to x to the power 4. And that'll be the case for any binomial expansion where this is a natural number. In year 13, we start to look at examples where this is negative or fraction or both. I'm going to run through two examples, two simple examples, and then get on to some more complicated ones later on. The formula for the expansion, a binomial expansion where this is not a whole number, is given to you in the formula books. You do not need to remember it, though of course you need to be able to use it. There's the formula as given to you. It's one of two. This one here, this number, the fact that this is a 1 is very important, because one of the examples we need to look at later on is what happens if this is not a 1. This expansion only works if this is a 1, but it can work for any value of n. Negative, positive, fractional, whole number, doesn't matter. And here is the expansion. 1 plus n times x plus n times n minus 1 x squared over 2 factorial, n times n minus 1 times n minus 2 x cubed over 3 factorial, and so on. I'm sure you can see the pattern here. Now expansions where binomial expansions where this is negative or fractional go on forever. They do not stop. So any question that you come across will say by doing the binomial expansion of x for the first 3 terms of x, or up till x to the power 3 or x to the power 2 or something like that. It'll tell you how far to go with your expansion. I've written the formula out here up to and including x to the power 3. But obviously I could go on x to the power 4, x to the power 5 if I had nothing better to do with my time. Okay, so the first example we're going to look at, we're going to expand 1 minus 2x. Well, as you can see, this is not written in that form. So the first thing I have to do is to rewrite this in that form. So 1 minus 2x to the power of a half. And now I'm going to put my values into the formula. So I've got 1 plus n times x, that's a half, times all of this. I strongly suggest you write it out first and then you do your arithmetic later on. Plus n, which is a half, times n minus 1, a half minus 1, times x squared. X in this case is minus 2x. That's minus 2x squared over 2 factorial. And we'll do one more, plus n, which is a half, times a half minus 1, times a half minus 2, times minus 2x cubed over 3 factorial. So I haven't done any working out yet. I'd strongly suggest you do it like this for two reasons. One, it shows you know what you're doing. You may get some method marks. And two, you're less likely to make silly errors if you set it all out. All right, and now I'm just working things out. A half times minus 2 is minus 1x. A half times minus a half is minus a quarter. Minus a quarter times whatever minus 2 squared is. Minus 2 squared is 4. So minus a quarter times 4 is minus 1. So I've got minus x squared over 2 factorial, which is 2. And we'll do one more. This could be interesting. Half times minus a half is minus a quarter. This is minus 3 over 2. So minus a quarter times minus 3 over 2 is positive 3/8. So this is 3/8. Minus 2 cubed is minus 8. So 3/8 times minus 8 is minus 3. So I've got minus 3 over 6, which is minus a half. I can either put a minus like this or plus a minus like this. It doesn't matter. So this is the expansion of this for the first 4 terms of the expansion up to and including x cubed. And that's how you do it. Make sure that this number here is always a 1. Now we can use this to work out approximations for various numbers. So let's say we wanted to use this to work out an approximation for the square root of 2. Now sometimes it'll be quite obvious how you're going to get square root of minus 2 out of this, and sometimes you've just got to go with what the question says, and hopefully at some point you'll have a minus 2. So the question is 1 minus 2x to the power of a half equals 1 minus x squared over 2 minus x cubed over 2. The question states by substituting in x is 0.01, find an approximation for the square root of 2. But when you first look at this, you'll go, well, where on earth is the square root of 2? I can't see it. Well, let's just substitute that in and see what happens. So I've got 1 take away 2 times 0.01 is 0.02 to the power of half, and that equals 1 take away 0.01 take away 0.01 squared over 2 take away 0.01 cubed over 2. Let's just press some buttons in our calculator, see what happens. This is 0.98 or 98 over 100. I'm doing 98 over 100 because I recognise straight away I may be able to do something with a square root here. And now I'm just going to press buttons on my calculator to work out what this is. 1 take away 0.01 take away 0.01 squared divided by 2 take away 0.01 cubed divided by 2, and I get 0.98895. Okay, I'm going to take the 100 out of the square roots. That'll make it 1 over 10 here. I have 1 over 10 here. I'm going to move over here times by 10. So what I'll have is the square root of 98 is this times 10, which is 9.8895. Now 98 I can spot straight away is 49 times 2. So this is 49 times by 2 equals 9.8895. Square root of 49 is 7. So this is 7 root 2 equals 9.8895. And there is the square root of 2. I wanted to have work out an approximation for root 2. There is my root 2. All I need to do is to rearrange this to get root 2 equals something. So 9.8895 divided by the 7. So times that by 10, divide it by 7, and I get 1.41279. Let's all round it off there. Well, let's compare that with what the square root of 2 actually is. 1.41421, so 1.414, that's accurate to sort of 2 or 3 decimal places. That's how you do a binomial expansion where n is a fraction in this case, would work exactly the same if it was negative, and how you can use the approximation to work out an estimate for this, let's say in this case, the square root of 2.